Okay, I'm going to try and wrap this up in one more video. So, alright, so we've got a skateboarder at the skate park. They want to design a new ramp. They're starting from rest at this point. Can they make it to this point? Okay, and the answer for that would be no. Okay. The total energy they have at point A is all the energy that they have due to conservation of energy. It's all the energy they can have due to conservation of energy. So, I mean, they can't make it to a higher height than that. They won't have enough energy. Can't make it to a higher H than point A. Okay, because they won't have enough energy to get there. Okay, an 80-kilogram diver jumps off a 12-meter high platform. How fast would she be going just as she touches the water, where her height equals 0? Okay, so in order to get that velocity, what we can do is get her potential energy at the top. So that's going to be 80 times 9.8 times 12 meters gives me 80 times 9.8 times 12, 9408 joules. And we know due to conservation of energy, at this point, she's got all potential energy, so that means that's the same total as her total mechanical energy. And then as she dives, that potential is going to convert into kinetic, so it's converting, right before she hits the water, okay, where her height is 0. Now all of her energy is going to convert to kinetic. Okay, so her kinetic at that bottom point is going to be 9408 joules. Because now all that potential has become kinetic. And then I can say 9408 equals 1/2 times 80 kilograms, that's her mass, times v squared, and solve for velocity. So let's just do it real quickly like that. So 80 times 1/2 is 40. I'm going to divide both sides by 40. So I've got to divide 9408 by 40. That gives me 235.2. And that's equal to v squared. Okay, that's not my final step. My final step is to take the square root of 235.2. And that gives me 15.3 meters per second for the velocity. And I did it that way putting in numbers. Okay, you could also use this equation we looked at in the last video where we just solved this for velocity. So you can do it either way. Okay. How much work is done to raise a 1200 Newton car up 2 meters onto a trailer? So remember, work is force times distance or displacement. So we're raising this car. So the work we're doing here is going to be a force of gravity in terms of our force, because we're having to overcome the force of gravity of this car. They already gave us force of gravity here. They gave us this in newtons. This is a weight, 1200 newtons. So I can just do 1200 times 2 meters. That's going to be 2400 joules. It's just 1200 times 2. Okay. So whenever you're lifting something, your force that you use to get work is force of gravity. And we practiced with that like a lot Friday or yesterday in our activities, and then also when we did the stairs lab the day before that. Okay, a family just bought a new fridge. They want to move it to the kitchen. They apply 400 newtons of force, but it never moves. How much work did they do on the fridge? Unfortunately, they did 0 joules, okay, because there was no displacement. Okay, if we look at work equals force times distance, they applied 400 newtons of force to this refrigerator, but they moved it 0. So 400 times 0 is still going to give me 0. So they have a problem. Okay. How much power is generated by a warehouse worker who lifts a 200 Newton box up onto a 2-meter high shelf in 3 seconds? Okay, so power is work divided by time. In this case, we're lifting again, so our force is going to be the weight of this box, which is our force of gravity. We're lifting at a distance of 2 meters. And then we're doing that in 3 seconds. So we've got force of gravity times distance divided by time to get our power. So we're going to have 200 newtons times 2 meters. That's my work. Divided by 3 seconds. And that's 400. 200 times 2 is 400. Divided by 3 is 133.3 watts of power. Okay. All right, during a lab at school to explore work and power, 2 students climbed the stairs. We did this the other day. Student 1 weighs 520 newtons. Student 2 weighs 630. They each climb up 3 meters in 7 seconds. How much work does each student do, and how much power do they generate? So student 1 does work of force of gravity times distance or displacement, because they're climbing the stairs. So their force is their weight or force of gravity that they're having to overcome. So 520 times 3 meters. Okay. Let's see, gives me 520 times 3 is 1,560 joules of work for the first student. And then the first student's power is that 1,560 divided by 7 seconds, because that's their time. So they had 200, I'm just going to round that, 223 watts of power. Okay, then student 2 had 630 newtons of force. Same 3 meters. 630 times 3 is 1,890 joules. And power is the 1,890 divided by the same time. So they have the same time and they had the same distance, but they had different forces because they had different weights. So the student that had more weight had a greater work value and a greater power value because this number is larger. Okay. Then the 630 Newton student repeated it, but they timed themselves walking up slowly and then walking up quickly. What would be true about this student's work done and power between the 2 trips? So this student walked up slowly and then walked up quickly. Their work is going to be the same between those 2 events because they are the same, exerting the same force each time because they have the same M times G, and they're walking up the same flight of stairs, so they're going to have the same distance. Power is going to be different because if they walk up more slowly, then they're going to have less power. You're basically dividing by a larger number here on the bottom. If you walk up quickly, you're going to have more power, okay? So power is different. Slower time equals less power because you're dividing by a larger number, okay? If I walk up the stairs super slow, I'm going to have less power than I will if I walk up quickly. So faster time equals more power. And that's because power is a rate at which we do work over time. So if we do work in less time in one instance versus another, then we're going to have more power. It's really like an inverse relationship because time is on the bottom. Okay. Okay, that's all. That's the whole study guide. Ta-da!